Hi, my name's Robert Wolfe. I'll be discussing research on hypodescent and visual semantic AI. This research examines whether visual semantic AI, specifically CLIP, associates according to a rule of hypodescent, or one-drop rule. We also examine whether CLIP encodes a default race and whether it exhibits stereotypical valence bias. The model we examine in this research is CLIP. CLIP jointly trains a language model and an image encoder and uses cosine similarity to pair an image with its text caption. This allows CLIP to rank, retrieve, and classify images using natural language. We start with a straightforward question. Are multiracial individuals associated more with the minority group than with white in CLIP? To answer this question, we based our study on psychological research in human subjects, which morphed images of Asian individuals or black individuals into white individuals. To achieve a similar design, we morphed images of individuals who self-identify as Asian, black, or Latino in the Chicago Face database into images of individuals who self-identify as white. We used StyleGAN2 ADA for this. Following the research with human subjects, we created 19 intermediate images between the Asian, black, or Latino image and the white image, for a total of 21 images per series. We created 1,000 series for each pairing by selecting different combinations of images from the Chicago Face database. The results showed that 89% of Asian white female images are associated with Asian at the middle step of the morph series. Similarly, 75% of Latino white female images are associated with Latina, and 69% of black-white female images are associated with black. 53% of black-white male images are also associated with black. The results reflect hypodescent in the model with a primary effect for women. Next, we asked, does person equal white in visual semantic AI? And we found that across the morph series we generated, the cosine similarity of an image with a person text label is nearly indistinguishable from that of the white text label, suggesting that white is encoded as a default race and that other races and ethnicities are defined in the model based on their deviation from white. Finally, we asked, does bias correlate with association with black in visual semantic AI? We used the single category embedding association test to obtain a statistical measure of each image's association with pleasantness versus unpleasantness. We found that images of white individuals were more associated with pleasantness in comparison to images of black individuals, and that this bias also extends to images of multiracial individuals. So what effect might this bias have on AI and on society? First, models which use the CLIP embedding space are likely to inherit the biases learned by CLIP. For example, the DALL-E 2 model card notes that it overrepresents white individuals in the images it generates, which may be a result of CLIP encoding white as a default. Moreover, the associations of models like CLIP may end up influencing how humans perceive other humans. So what are the takeaways of this research? First, visual semantic AI associates multiracial individuals according to a rule of hypodescent, with a primary effect for images of women. Second, white is encoded in CLIP as a default race. And third, intrinsic bias magnitude correlates with association with black in the model, and this bias extends to images of multiracial individuals as well. Please feel free to contact us at these emails with any questions. Our code is public on GitHub. Thank you.